follow along on this worksheet. We're going to do a good portion of it together, and then you'll have just a small assignment for your own. The parents of the Clark children work hard to ensure that their kids understand being financially self-sufficient. Each child oversees some form of a business during the year. Lillian, age 8, pulls weeds in her neighbor's garden, while Scott, age 6, feeds and waters their neighbor's dog. James, age 10, runs a lemonade stand. Lillian bought a pack of gardening tools for $20 to aid her in her job, and her neighbor pays her $4 a week for her services. Scott was given $4 to begin the job and is being paid $1 a week to take care of the dog. James's lemonade stand has a profit as a function of weeks open, modeled by negative x squared plus 36x minus 260. So we need a chart for each one of these. So let's start with Lillian's. So this will be Lillian's chart. X's and Y's. So when this story begins, she's already spent $20. So 0, negative 20. And each week she gets paid $4. So we're going to add 4 to that. 1, negative 16, 2, negative 12, and so on. Okay. For Scott's chart, Scott was given $4 to begin the job of, well, what was it? Watering the neighbor's dog. So 0, at time 0, he's made $4, and then $1 after that. So 1, 5, 2, 6, 3, 7, and so on. Okay. James's chart is going to be following this function, negative x squared plus 36x minus 260. So to figure that out, I'm just going to plug in values. I'm going to plug in 0, negative 0 squared plus 36 times 0 plus, oops, minus 360, 260. So 0, negative 260. We could plug in 1. So second, enter. And I'm just going to go back and change all those zeros to 1s. Negative 225. I think I messed something up. Negative x squared plus 36x minus 260. Okay. So 1, negative 225. And 2. So you can see that he's starting to make money, but he still hasn't profited anything. 192. Well, I could graph these by hand, but we're going to graph them using our calculators. So I need to know what the functions are. Well, I know that Lillian's job is linear. So this is a linear equation. And I know that Scott's job is linear. So we need to figure out what the equations are for each of those linear functions. So go ahead, plug in 2 numbers into your stat plot, do a linear regression, and we'll pause the video and we'll come back and we'll tell you what those 2 equations are. So pause the video right now. So for Lillian's equation, you should have gotten y equals 4x minus 20. And for Scott's equation, you should have gotten y equals x plus 4. Now we're going to use our calculators to answer each of these questions. But first we need to graph it and then set our window to something that will allow us to actually see the graphs. So I'm going to go in, let me block these. This one. Okay. Oops, that didn't work. So Lillian's I'll put in y1, 4x minus 20. Scott's I'll put in y2, x plus 4. And James's I'll put in y3, negative x squared plus 36x minus 260. And I push graph. And you can see James's graph barely shows up at all. And I need to change my window. I don't need to know any time in the past, so I can change my x minimum to 0. And by looking at the graph, I'm going to need to know more on the x-axis. So maybe I could go out to, say, 30. So my x max is 30. Graph that. And now I need to go up a whole bunch. I can't see the intersections, so maybe from negative 10 to 100. Let's see what that looks like. That's pretty good. So those are the three graphs. So graph those on your paper, and they just kind of got to be close. Number 1, which job would you prefer? Well, there's not one answer to that. So Lillian's graph is the steeper one. So that's Lily. Scott's graph is the shallower linear graph. And James's graph is the parabola. And it looks to me like, depending on how long you want to keep the job, depends on whose job you're looking for, which one would be the best one for you. Okay? So it looks like Scott's is the highest for a while, then Lily's is the highest. So Scott's is the best job from there to there. Lily's is the best job from there to there. And James's job is highest there, and then after that, Lily's job has the best, the most profit. So it depends on which job or how long you want to work. Okay, next question. Does James run a profitable business? Does James run a profitable business? Well, looking at that, is his graph above the x-axis? And the answer is yes. It's above the x-axis from here to here. So as long as he quits somewhere in that point, he will have made money. If he quits too soon, he won't have made enough to pay for his debts. If he quits too late, he will have more debts, and he will have lost money. Okay, number 3. How can you account for the shape of James's profit curve? So you need to write something that describes why he started out negative 260 in the hole, and then he gained a bunch of money, and then he started losing money. So you need to come up with some reason, something to do with his lemonade stand that explains why the graph would be shaped that way. Okay. And then the rest of these questions you're just going to answer using the calc button in your calculator. So number 4, what is the most that James can expect to earn? So you're going to use your calculator and do second calc maximum. And the trick here is we actually have 3 graphs. So in the top left corner you see y1, and you see the cursor on Lily's graph. If I push up, then it jumps to y3, which is James's graph, and I push up again, and it jumps to y2, which is Scott's graph. So you need to make sure that you're on the appropriate function when you try to find the maximum or the minimum. So I want the maximum of y3, and right now it looks like I'm at x equals 15. So left bound, I'll choose 15. Right bound, maybe 25. And you can see that my maximum is between those 2 arrows. And my guess, I'll make a guess of 20. My maximum value is at 18,64. So 18 weeks into his job, he will have made $64. So the maximum is 64. Okay, for number 5, when would Scott's and James's businesses have the same total profits, and what are those profits? So it wants to know, hold on a second, wants to know when does Scott's graph intersect James's graph? And there are 2 points. It wants to know when does that happen and how much money were they both worth at those points. So, and again, you have to be careful that you pick the correct graphs. So second calc, I'm going to go down to intersect. And again, I have y1, y3, and y2. I want the intersection of y2 and y3. So right now the calculator is asking me for the first curve. I need to push enter on either y3 or y2. So push enter on y2. And for my second curve, notice it will let me highlight y2 again, so don't highlight that. Go up to y3 and hit enter. And there are 2 intersections. So first I want to go down here to the first intersection. I hit enter. So the first one is at 11 years, they were both worth, or not years, sorry, 11 weeks. They're both worth $15. And then we need to find the second intersection. Second calc. Go to intersect. First curve. Let's go up to y3. Second curve, y2. And then I'm going to go way over to the right at that intersection and hit enter. So at 24 weeks, they were both worth $28. They both made $28. Okay. So number 6. When would Lily's and James's business have the same total profits, and what are those profits? So you need to find the intersection with Lily's graph and James's graph. Number 7. When would Scott's and Lily's businesses have the same total profits? Okay. And then number 8 is the tricky one. For which weeks would each job be the best job to have? So if I zoom in on the graph a little bit, I want to know what is the domain. It didn't work very well. There we go. So I want to know, this is Scott's graph here. I want to know when is Scott's graph the highest graph? What are the intervals? From like 0 to 4 or something like that. Scott's would be the highest. And then I want to know when is Lily's the highest and when is James's the highest, and so on. Okay? And then the rest of your assignment today is to turn the page and answer questions 1 through 4, which is you have 2 graphs, graph each of them and find all of the intersections. There is a 3rd page to this assignment, but we're not going to do it till I come back. So just finish the first 2 pages of this and don't turn it in. And I'll be back tomorrow.